Myrtaceae family, which is originally from Australia, but are found in the Arboretum. We looked at 4 species. 2 of them were upright trees, and 2 of them were bushy scramblers. So in this study, we asked the question, how do these 2 different life strategies change the water transport within the same family? And we hypothesized that the upright trees would show lower conductivity, more negative water potential, and larger xylem conduits than the low-to-the-ground scramblers, because we thought gravitational pressures of an upright tree would have these differences.
We measured the following variables for our study. Water potential was measured using a pressure chamber, hydraulic conductivity was measured using a hydraulic apparatus, and we used cross sections and analyzed them through ImageJ to find conduit diameter. The first 2 variables, we did 2 replicates, and for conduit diameter we took 10 measurements for each cross section, and all of the results were statistically analyzed using t-tests.
For our results, we didn't get statistical significance between upright and scramblers and xylem hydraulic conductivity. We got 0.2 to 0.3 kilograms per meter squared megapascals. We also didn't get statistical significance between xylem conduit diameters. They got variables between 17 to 18 microns. We did, however, get statistical significance in water potential. Upright species had negative 0.7 megapascals, while scramblers had an even more negative water potential of negative 1.32 megapascals.
Our water potential did have statistical significance, though it did not fit our hypothesis. And we are still trying to figure that out, so we'll keep you posted. For our results for conduit diameter, we saw no statistical significance. So for that, we looked to Olson et al. 2014, who said there's a positive relationship between conduit size and stem length. So while we were in the field, we did see comparable stem lengths from both the scramblers and the upright trees, though we didn't measure this at all. So we suggest to get more of a solid conclusion with our results to measure the stem lengths of our plants and to see what conclusions we can draw from that.
For these different life strategies, they both had similar xylem hydraulic conductivity, and we think this is because all the species that were chosen for our experiment are grown in semi-pervious poor soils, and according to the study of Baer 1972, it suggests that soil type is related to hydraulic conductivity. And according to his table of what species hydraulic conductivity should be for poor soils matches our results.
Further funding is needed to gain a better understanding of the physiological differences within this family and the physiological costs and benefits of having different life strategies.
Done!